The objective of this lesson is to use reasoning to develop the formula used to calculate the area of a trapezoid. Trapezoids are two-dimensional figures that have at least one pair of parallel sides. The two parallel sides are identified as the bases of the trapezoid. Height is the measurement that is perpendicular to the two bases. Let's start with the following problem. Mrs. Green's backyard has a trapezoid-shaped area of grass. How many square meters of grass is it? In a trapezoid, at least one pair of sides are parallel. In this trapezoid, the top and bottom sides are parallel because they follow the grid lines. Let's think about other shapes we know and see if that would help us find the area of the grass. In a previous lesson, we discovered that we can find the area of triangles several ways. We could decompose triangles into rectangles, parallelograms, or trapezoids. We found we could find the area of a triangle by taking 1/2 of the base times the height. One way to find the area of this trapezoid is to cut the trapezoid into two triangles. Now we can find the area of both triangles by using the formula area equals 1/2 the base times the height. One triangle has a base of 10 units and the other has a base of 5 units. Both triangles have a height of 8 units. 1/2 of 10 times 8 equals 40, and 1/2 of 5 times 8 equals 20. When we add the two triangles together, we will be able to determine the area of the trapezoid. 40 plus 20 equals 60. The grass in Mrs. Green's backyard is 60 square meters. Let's think of another way we could find the area of this trapezoid. We know how to find the area of a parallelogram. It's the base times the height. How could we use that formula to help us find the area of this trapezoid? If we place a congruent trapezoid next to the original trapezoid, we create a parallelogram. The area of a parallelogram can be calculated by multiplying base times height. Our new parallelogram has a base of 15 units and a height of 8 units. 15 multiplied by 8 equals 120 square units. Since the parallelogram was created by doubling the trapezoid, we need to divide the 120 units by 2 to find the area of one trapezoid. 120 divided by 2 equals 60. The area of the trapezoid is 60 square units. Mrs. Green's backyard grass is 60 square meters. These are just two of the possible ways to use reasoning to find the area of a trapezoid. Now let's look at how these two methods can lead us to the equation for finding the area of a trapezoid. In the first method, we found the area of both triangles. If we give each base a name, base 1 and base 2, we can see that we found the total area by multiplying both bases by the height of the triangles and then multiplying each triangle by 1/2. We will use our algebraic reasoning and remember the 1/2 and h, or height, can be factored from both addends to be written as a equals 1/2 h multiplied by the sum of base 1 plus base 2. This is the formula we discovered for finding the area of a trapezoid. In the second method, we created a parallelogram from two congruent trapezoids. If we also give each base a name, base 1 and base 2, we can calculate the area of the parallelogram by adding base 1 and base 2 and then multiplying by the height. But because one trapezoid is only half of the parallelogram, the total area needs to be divided by 2 or multiplied by 1/2. That leads us to the formula area equals 1/2 of the height multiplied by the sum of base 1 and base 2. This is the formula we discovered for finding the area of a trapezoid. Let's now use the formula for finding the area of a trapezoid to solve some area problems. Valley Park covers a trapezoid-shaped block. The parallel sides are 2,500 miles and 3/10 miles long. The shortest distance between the two parallel sides is 2/10 miles. What is the area of the park? To solve this problem, we will add the area of the two bases. 25 hundredths plus 3/10 equals 55 hundredths. We will then multiply the 55 hundredths by the height, which is 2/10 of a mile. This equals 11 hundredths. We will then multiply the 11 hundredths by 1/2 or 5/10. The area of Valley Park is 55 thousandths of a square mile. Let's solve one more trapezoid problem. Samantha cut a piece of trapezoid-shaped fabric to make a skirt. What is the area of the piece of fabric? We will first add the two bases. 24 plus 32 equals 56. We will then multiply the sum of the two bases by the height of 20 inches. 56 times 20 equals 1,120. We will then multiply this product by 1/2, which equals 560. The area of the fabric is 560 square inches. The objective for this lesson was to use reasoning to develop the formula used to calculate the area of a trapezoid. We met this objective by manipulating the trapezoid shape to determine the formula for finding the area of a trapezoid. We then used that formula to solve real-world trapezoid problems.